Hello, I made some additional tests regarding the scalar wave behavior. So I took a small inductor which has more or less the same inductance than the microampere meter. It's around 6 millihenries. And I have attached a small signal diode and a current sense resistor to see on the scope what's going on here, why I can get so only current flowing in one direction and not in the other. At least in the meter this was happening. So this is the reading of the current. The current sense resistor is 10 ohms. Due to the small current I had to use a big one. This would be quite consistent now, what we see on the scope. We see there are positive spikes of current, which is according to the polarity of the diode would be logical, which the relatively big inductance will block the pulse in the other direction and let it only flow in this sense. Okay, now I put the diode in the other direction. You can see it's in the middle line. There is some small interference from the coil, but as it is attached to the resistor, there cannot be too much interference present on the scope. So we'll see what happens now. I will attach the same bay as before, but the diode in inverse polarity. Okay. So we see we have the same pattern on the negative side now. So the only thing that remains to test why there was no reflection of the microampere meter on one side when I used it with the diode. So when I attached the probe, the signal, directly to the scope, to the side, to the other side of the diode, there is no polarity present. There is, it seems to cancel out. It flows in both directions, the current. So I made an additional test with this setup with an ultra-fast diode type to see what happens, why the other diodes couldn't rectify these currents. So I will attach the probe of the receptor. And the cause is clear. The diode cannot rectify it. Simply like that. It's AC. It do not respond at that high frequency, it seems. Remember, the coil is near 5 megahertz. For completeness, I have changed the polarity of the diode, and there is now some some displacement visible. The spikes on the positive sides are higher, but it seems to block a little bit better in one direction than in the other. This normal ultra-fast diode. Now I have soldered this silicon carbide rectifier from Cree to make the same test. So again we have a slight shift toward one side, but the current passes through. It is not properly blocked, and I think at this moment this is not due to the reverse recovery time, but the internal capacitance of the diode. For this reason, the small diodes perform much better than the big ones. Okay, here the last one with Schottky rectifier. See the scope? It's the same. So I believe it's the size of the silicon chip inside the diode which makes the difference.